Hey guys, how's it going? I hope you had a better January than I did. This is a little bit of a weird month for me. I had car problems, I got sick, and as you'll see in this video, I made maybe 2 or 3 million mistakes machining. I decided to make some handles. I had shown in my last video this new design that I'm working on that allows you to switch out different scales of different materials for more customization. I thought I'd start making these handles, and I'm going to start with stainless steel first, but I think I want to try machining titanium too. So let's just jump into it. After facing the back, I mill out a pocket for a bearing. The pocket is shallow. It's only there just so that the bearing doesn't really slide around and get caught in a groove in the pin. Next, I rough out a hole for the pin. In this new design, the pin can't rotate in the handles, only slide up and down. I decided to drop the reamer and just mill out the holes so that I can have more control of the size. And I finish up the main pin hole with the same end mill to get the small corner radius I need. After some deburring, I can clamp the piece to a fixture I made. I haven't been very good at using the same fixture for a long time. I'll explain why this one's wider and has holes at the top later. First, I faced the top. I don't want to hit the screws though, so I tried out different methods of facing the top so that I could get nice looking tool marks. The next step is milling the pocket for my scale inserts idea. The pocket material is removed in an adaptive toolpath. I then switch to an 1/8 inch end mill to get into the corners and mill a pocket for the screw head at the top of the handle. Okay, here's where it's more stressful. I wanted a little step for inserting these handle scales to lock them in. This means I need a little undercut in the handle. So I have to use a T-slot cutter with a thin neck. Or, maybe I could have gone with a dovetail design instead. Yeah, it'll probably be fine.
That's not a good noise.
It actually didn't break. Okay, it sounds chattery. So, at the risk of putting more load on the tool, I'm gonna slow the RPM down a bit. Hey, that sounds pretty good. Alright, next I gotta swap some screws. This lets me do the outside machining and the step. In my last video I talked about avoiding bending. I decided to only machine the finishing pass below the bullnose radius. This is so that I can leave extra material on the side that the next piece can lean on. I decided to go with a 3/32 round over. I think it'll be easier to manipulate the handles than with the 1/16 inch round over. It came out pretty nice. Not much to say. 1 down, 3 to go. I thought milling the pocket was a little slow, so for this next one I tried setting it so that the mill would cut both climb and conventional. Fusion decided to do this. Just took a big bite out of my part. It's kind of interesting. I should have paid more attention to what the toolpath looks like, but come on. Why would it do that? I was able to get rid of the extra loops by changing some of the lead in and out parameters very slightly. That definitely seems like a bug and not really my fault, I guess. What is my fault though is somehow not realizing until now that I made the corner radius in the pocket too small for the 1/8 inch end mill I was using. So I had to finish up the corners with a 1/16 inch end mill, and then the little scale clip could fit perfectly. Time to stress out about the T-slot cutter again. And finish the outside. I made a couple more. Wait a minute. Um, uh, mm, wait, I somehow programmed the T-slot cutter as if it was a 3/16 inch cutter when it's a 1/4 inch cutter. So it was taking way bigger cuts, and it didn't break. Well, maybe this would be a lot less stressful if I actually program it correctly and don't cut away way more material than I need to. Well, that's actually not true. I was able to get one that was correct before I broke both of my T-slot cutters. I don't know, I'm switching to dovetails. Took a little bit more effort to design than I expected. Ironically, for the dovetail to be able to work, I do need to cut a little bit into the sides. And I didn't want to make the wall too thin. And not every angle and size of dovetail is readily available. I wanted to make sure I could get a size that I could also easily get a tapered matching end mill. That way, I don't have to be forced to flip the part upside down if I don't want to when I make the scale. I decided to go ahead and make it tapered on both sides, which means I'll have to make new clips too. But that's okay, cause I was going to anyway, cause I don't want to have to use a smaller end mill in those corners, so I want to up the radius anyway. On this next one, I decided to go ahead and just try ramping down the pocket with a 1/4 inch end mill. This is 3 times as fast. Next I can do the dovetail groove. It's much less scary with the dovetail. Much less cutting forces being applied to a small area. Speaking of stranger shaped cutters, I've gotten better at deburring my parts in the machine. I decided to try one of these back deburring tools so that I can try deburring the backside of the part. I cut an even deeper groove than I needed when I cut the outside. Then I could use this tool to put a small chamfer on the bottom of the part. Nice. I made 4 more of the dovetail handles. One's a spare. I think it's finally titanium time. A while ago I posted a picture on Instagram of some titanium I got water jet cut. I like Grimsmo knives and I knew he got his handle blanks water jet cut, so I thought that might be something I have to do too. I was able to get a small plate from McMaster. The titanium I got is grade 2, which means that it's 99% pure titanium. This is a less common grade, and it's less strong. Here you can see on this Rockwell hardness chart I made with numbers from McMaster, it's the same softness as mild steel, and I guess it's less strong. Here you can see grade 5, which is stronger and harder. It was easier to get, but now I have some grade 5 too. But I've been stepping up gradually, so maybe it's better to start with this anyway and then work up to grade 5. I got these blanks months ago, so things in the design have changed. I'm not going to just throw away a bunch of titanium though, so I tried to make a fixture that would still work. I also got some new end mills with more flutes. Now, from what I've learned, is that titanium is very poor at transferring heat. Taking lighter cuts helps reduce this heat. So by increasing the number of flutes, just like how you might when you go from aluminum to steel, it allows you to remove more material despite the smaller cuts. Speaking of heat, it is possible for titanium to set fire apparently, which I'm guessing is worse with my pure titanium, and apparently you can't put it out with water. So I got all my non-water fire preparedness stuff together, and I guess we're gonna give it a try. Uh-oh. Oh boy. At least it wasn't a speeds and feeds problem. Wasn't even a titanium problem. What happened there is, for some reason my post-processor stopped listening to what work offset it's supposed to be set to. Yeah. Let's try that again. That's better. I cut away some extra material while avoiding the screws. Then I finish up most of the top. I do some drilling next. The chips are very stringy. The material is really soft. I should have pushed the drill harder. I was able to widen the holes with the 16th inch end mill pretty easy. Then I can deburr and swap the screw positions. I finish the last bit of facing, and then I start milling a pocket for the bearing. And milling the hole for the pin also seems to go well. Next I can screw the water jet cut blank to the other side of the fixture. Here's where things get a little dicier. I decided to switch back to the 3/16 inch cutter for the pocket, except I'm using one with 5 flutes instead of 4. I thought that I would try to do thinner, lighter radial cuts like I said, and it loaded up almost immediately. Here's where I started thinking more about how I should use coolant. To make filming easier, I've been using the fog buster with an air blast with an oil mist as coolant. For titanium, I was worried that maybe the heat would get hot enough that a bunch of vaporized oil in the air wasn't the brightest idea. So I turned off the oil. But now there's no lubrication, and I think things are even hotter. So this is a recipe for chip clogging. I figured I'd go back to my old strategy for the pocket. I could experiment more with feeds and speeds when I am milling the outside and there's more room for chip evacuation. Things start looking not great, so I decided to switch back to my usual 4 flute end mill. The thin axial cuts are still clogging up the cutter, but geez, this material is stringy. It's not really clogging up now, it's tangling up. I've never seen something quite like this. I tried messing with the feeds and speeds, but it just doesn't seem to be working. Even doing a 5 thou finishing pass was risky. Oh, great. Well, I guess it made it to the end. And the deburring's fine. Now for the outside. It started promising, but it's just too sticky and stringy. Just one little bump and it clogs up. So I decided to edit the speeds and feeds. And I thought, hey, this end mill doesn't have a corner radius, so I can go ahead and just go deeper on all the passes. I'm an idiot. Well, now I'll have to re-flatten the fixture later. Okay, so I'm just going to give up on that and go back to the 4 flute with the corner radius. It was a bit sketchy, but I did it. The corner rounder was fine. I probably did more passes than I needed to. And then I accidentally didn't record the last bit of deburring. It was pretty late at this point. So here's what it looks like finished. Somehow, despite all that, I don't think I'd call this part scrap. It's not pretty, I wouldn't sell it, I guess, but I'm glad I didn't have to go through 5 of my water jet blanks to be able to get to this level of success, so to speak. And look how light it is. That's pretty cool. I made some more spacers so I could see how everything fits together so far. There's nothing really different about them except that I did backside deburring on them. Because of some of the changes I made, the new handles with the dovetails aren't compatible with the rest of the parts. However, I always make sure to buy a backup of a cutter, so I didn't show it, but I was able to make 4 handles with the T-slot cutter. I looked at all sorts of feeds and speeds for titanium, and I wonder if the speeds and feeds I was looking at would have ended up working better on grade 5 titanium. I'm going to go back to stainless until I make some changes with the coolant. I think coolant will make the biggest difference, but I want to hear other people's suggestions if they have them. The button is clickable, but it's a little stiff. I switched to using this diamond cutter for making the grooves and the pins. For the test piece I made, I used two 60-degree triangle insert cutters, and so it was a little bit easier to click up and down. I didn't want to have to use two tools per groove though. But now I've realized that I only need to use one tool per groove. I have to use two tools overall, but I can just put one on each groove. It doesn't need to be symmetrical. I'll probably make some new pins and see how it's different. I guess I'll be making a lot of new things, because apparently I designed this in such a way that one handle can't move. I'm gonna call this last month 2 steps forward, 1 step back. Or maybe like 29 steps forward, 24 steps back. I don't know, I sort of making progress, I think. I'm gonna go fix my 3D model. I know what I did and I'll be able to fix it. I'll see you guys next time. Have a good one.